All right, let's do 13.6, solving rational equations. We've really dealt with this topic a little bit already. And so how do you deal with it? Well, solving rational equations, like anything else, you have to multiply both sides by the LCD. It's the same concept as removing fractions from a problem. Now, there's one other aspect to rational equations. And notice these, there's a variable in the denominator. Therefore, we have to be on the lookout for what? What can't we have? Excluded values. So, be sure to eliminate, and I mean from your solution, any excluded values. Be sure to eliminate any excluded values from your answers. Now, there are a lot of answers to a problem, and the excluded value may not be one of them. And quite honestly, in most cases, the excluded value is not one of the solutions, and therefore you're good to go. But you always have to be aware of the excluded values, because if you get an answer that's an excluded value, you have to cross it off. It's not a solution. And so, for example, in A, if we were to name the excluded value, what would it be? It would be when x equals 1, right? Because that would make the denominator 0, and that's no good. All right. Now, we don't usually list them. Sometimes a course will give you a problem and say list it, but we don't usually list them because they're values we can't have, but it's got to be in your mind. You got to be aware of it. You got to be thinking of it. It's got to be on your radar. Well, a problem like this is very, very easy. The LCD is very obvious, right? It's in x minus 1. And honestly, because there's just a fraction on the left and quote-unquote a fraction on the right, 4 over 1, if you wanted to, you could just simply cross off the x minus 1 right now by moving it to the top on the right. And I usually say things like this: things on the bottom go to the top across the equal sign. Now, why? Because technically, you multiplied both sides by the LCD, and on the left, they divided out, right? So the shortcut is just cross it off the bottom, stick it on the top right. Because again, on the left, they would divide out, right? Multiplying both sides by the same quantity. And now it's a pretty easy problem, right? Any of you can solve it. This is a pre-algebra problem now. And you say 5 equals 4x minus 4. And so move the 4, and we get a 9, and divide by 4, and you get 9/4, and x is 9/4, right? And again, Algebra 1, we should be able to speed up and take things at that speed, right? Not a problem. No problema. Piece of cake. Everything's fine. Everything's grand. We're happy. So the second one is similar, right? So the overall concept, multiply both sides by the LCD, but can you do the shortcut on this next one? You can. Is there a fraction on the left? Yes. Is there only a fraction on the right, or just a number, which can be a fraction? Yes. Whenever there's just one fraction on the left, just either a number or a fraction on the right, you can do the shortcut. Again, things on the bottom, I'll use my green here, go to the top across the equal sign. Again, how does that work? Because technically I'd multiply the left by n minus 1, and the n minus 1s would divide out. All right, piece of cake. So now let's finish the problem. We have an n minus 3 on the left, 6n minus 6 on the right, right? Just distributed. No big deal there. Remember, variables on both sides, get them all on one side. So that's going to leave me a 5n on the right, right? Because I'm going to add a negative n to both sides. I'm going to add a positive 6 to both sides. It's going to give me a 3 on the left. Sneeze coming. Sorry about that. And now let's just move the 5. And so n is 3/5. Is that a viable value? Yes, it is. As long as we didn't get 1, we're happy. Are you happy? Look at Byron. He looks so happy back there. He's happy. Everybody's happy. Raquel. Right? Good to go. Pretty simplistic. Again, look, Algebra 1, end of the year. Look, did I show work on that problem, yes or no? I did. Did I show every step? No. And look at this. This is the point now where if you don't have to, then you don't need to show every step. We've now done it enough to where it's set in our minds. We've got the patterns down. We're thinking clearly. Fine. If still for you, you're better off doing every step. Otherwise, you'll make a mistake. Do every step. But it's not needed. But is there work? Oh, yeah. There's work, right? And you see the work, and we're going along. This is how we'll approach it in Algebra 2 as well. Okay, so here again, we can do the shortcut. Fraction left, fraction right. Agreed? So what do I multiply the left by? Talk to me. No, what do I multiply the left by? Things on the left go to the top across the equal sign. Things on the right go to the left across the equal sign. You got to take the x to the minus 4 from the bottom right and multiply it top left. Now, what do we multiply the right by? And look, understand again, this is just a shortcut. So just pause with me, all right? I just want to make sure that you guys are catching what's going on. Let me show you the full-blown thing. This would be full-blown. Don't write this. I would multiply the left by 3x times x minus 4 and the right by 3x times x minus 4. But notice what will happen. On the left, the 3x's divide out, just leaving me the x minus 4 times 4, which is what you have, right? And on the right, the x minus 4's divide out, leaving you just 5 times the 3x, which is what you have, right? Again, it's just a shortcut. You can do it if there's just a fraction left, fraction right. All right, finish it out. You finish it out. I'll finish it out while you do, and I'll see if I get to Scotland before you. All right. In other words, you take the high road and I'll take the low road. Is the solution allowed? Yes, as long as we didn't get 0 or, what's the other excluded value? 0 or, talk to me. Earth to class. 0 or 4, right? So negative 16/11 is good to go. Be careful, you got to distribute. If you're not good at distributing from the back, stick it in the front and distribute, okay? Whichever is going to get you the higher probability of getting the problem correct. How many got that correct? Okay. All right, D is exactly the same again, right? By the way, let's talk about the excluded values of D first off. Our variable cannot end up being what two values? -1 or +3, right? Okay, so go ahead and solve that. You solve it. I'll do mine up here while you do yours down there. Again, if you distribute better from the back, then stick the term behind it. Get all confused and do it longhand. Write the whole thing out. X is -9. Let me ask you something. Is there always a solution to these? The answer is sometimes there might not be a solution. because of the way the numbers are in variables, because usually we have more than one variable in one place, it is possible that your variable might disappear. Poof. If your variable disappears, then there's no solution. It just goes away. It adds out. For example, what if here, instead of having 2x minus 6 equals 3x plus 3, what if we had on the right 2x plus 3? Wouldn't our x's add out and they'd be gone? Right? Presto, change up, whoosh. In which case you would say no solution, that thing. Well, in which case you would actually say, I shouldn't say no solution. In that case, the answer would be any real number. All right, we'll talk about that stuff later. You gotta look through to the end, I guess is what I should say on that, because there are lots of possibilities. All right, this one you cannot do the shortcut. No shortcut on this one. You definitely want to use the LCD. It'd be the easiest way of doing the problem. LCD. So let's first off figure out the LCD. So let me give you a couple seconds here. Figure out what you think is the LCD. All right, who wants to go for the LCD? Ethan, what do you think the LCD is?
6x minus 4.
So I think you meant 6x times the quantity x minus 4, right?
Sure.
Right, 6x times x minus 4, right? And you're treating that x minus 4 as a quantity. That is the LCD. How many got that? Really? That's it? All right, so I got to know. Somebody raise your hand and tell me what your LCD was. Come on. Give me some of your wrong answers. Come on. Kirsten, what'd you have? Okay, too big. But that is a common denominator. It's not the lowest.
I just
Long.
did 6x.
So just like that, and no parentheses or anything. Okay? What else? Madison?
18x minus 4.
So just like that? Like that. Okay? That's actually not, these last two aren't actually common denominators. That's okay. It helps me to know what you're thinking. Yes, Lauren? I mean, Kaylin?
12x times x
12x times x minus
minus 4.
4. Again, that's a common denominator, not the lowest common denominator. Okay, so let's go ahead and do it the old way, shot-wise, right? What do? You factor the number. Would you agree that a 3x is a 3 times x? And you know what? A 4x is just, an x minus 4 is just an x minus 4. Remember, they are one thing. They are one thing. And a 6x is a 6 times x, and a 6 is a 2 times 3. Agreed? Isn't this how we did every other LCM, LCD? We factored, right? Didn't we? Because look, can't something on the bottom, can it be like a binomial on the bottom? And how about like a difference 2 squares binomial on the bottom? How about a trinomial on the bottom that factors? Is that possible? Possible. And you got to figure out the LCD. How do we do LCDs? You factor the denominator. And then remember, you make a chart. I'll come over here and make my chart. I need a 3 column. I need an x column. That's the first one. My x minus 4 has to go in its own column. My 2 has to go in its own column. My 3 goes in the 3 column, and my x goes in the x column, right? Therefore, making the LCD 2 times 3 times x minus 4, or as Ethan said, 6x times the quantity, x minus 4. Does it make sense now? Look, factor, line up the factors. Every column gets represented once. It's a method. Let me ask you this. Was it hard to factor a 3x? No. There was no factoring to an x minus 4. Was it hard to factor a 6x? No. So did you remember how to do the LCD? That's the question. And that's, because, look, is it hard to put them lined up? That's not hard. 3's go in 3 columns, and X's go in X columns, and X minus 4's go in X minus 4 columns, and 2's go in 2 columns. So that's the idea. So you got to be able to get there, right, if you're gonna be able to get it correct. I like to use this as my multiplier of each term. Now, you can do it in the front or in the back. Most students like it better in the back. So this is 4 times 2 times 3 times X minus 4. And the 5 is times 2 times 3 times X minus 4. And the 1 is 2 times 3 times X minus 4. Right, we're multiplying each term by the LCD. Let me let you catch up. Any questions so far what we've done? Multiplied each term by the LCD. All right, so somebody raise your hand. What do you think you would do now? What is the next step? Adam? Not yet. Not yet. Andrew? Okay. Yeah. Look, if you are correct, everything's going to divide out. You'll have no denominators left. That's what we're trying to do, get rid of the denominators. So if you look, I'm going to use I'll use my red. On this first one, the 3's divide out, right? And the X's divide out. Agreed? No denominator, left term. On the second term, the X minus 4 quantities divide out, right? They're gone. And on the right, the 2's are gone, the 3's are gone, and the X are gone, right? We have no denominators left, and if you do things correctly, you will not have a denominator left. Okay, now it's just algebra. See if you can solve it. So, 4 times 2 is 8, and I've got to distribute that. 8 times X is 8X. 8 times negative 4 is a negative 32. That's the left term. On the right, 5 times 2 is 10. 10 times 3 is 30. 30 times X is 30X. That's the second term. And on the right, all that's left is X minus 4, right? I don't know what was taking you guys so long. All right. 8X and 30X is 38X, but add a negative X to both sides. That's a 29X. 38 minus 1 is 37X. And then add a positive 32 to both sides, and that's a 28. And looks like we end up with X equals 28 37ths. Oh, no excluded values. Bummer. I wanted at least one. How many got that correct? Gold star for you to end your school year.